be argued that solving equations is kind of one of the main goals of any math topic. And so you might say that everything that we've done up till now was to try to get us ready to do this. But some of the things that we've done up till now, like the proofs, was also just to get you guys to do some critical thinking. And you're going to find out that you use that kind of thinking next year in calculus. And we'll also use that kind of thinking when we solve some equations. The way I have the lesson organized is that a lot of students like to do this, that's why I gave you a piece of paper, is that there'll sort of be like 4 categories. And so if you would prefer to use the paper I gave you, which again, a lot of students seem to like to do that, you can make it look like that. Have you folded paper like this before? It used to be really popular some time ago. You just have to fold it in half, whatever halfway you want to fold it. You fold it in half, and then you fold it the other direction. So you kind of fold it in half twice, but so that you can end up with basically 4 corners. Now, if you want to fold it so you get the little spot in the middle, and you get these little tabs in the corner, one thing I would say is don't fold it too big. Okay, you don't want to get this giant space because you won't have room for your notes. But to get the little space in the middle, if you want, you take the closed corner. The closed corner. There's one corner that's closed in all 4 ways, and you just give it a little triangle fold. So again, you take the closed corner, you get a little triangle fold if you want to do that. And then the opposite corner, which is totally open, you also give it a little triangle. If you don't want to do this, it's fine. You can do your notes however you would like. All right, and you get a little space, or a little 4 spaces with something in the middle, and then those little corners. If it was me, I'd probably put in the middle the title, something along the lines of solving equations. And then what we'll do is we'll fill up each of these 4 spaces with 4 different categories. Just by the way, you may want to have just a good old calculator handy. Some of the problems, you'll find yourself the last step punching into a calculator. It's kind of been nice, though, not really using a calculator to do some math lately. All right, now you've actually solved some trig equations. Any equation that had a sine or cosine in it, and you ended up solving for theta or solving for x, that was a trig equation. And you actually solved some like that back when we were talking about triangles. They were kind of basic, but I'm saying that because you already have some skills. What I'm going to do is take that skill set and we'll sort of bump it up a couple notches, because now the equations can be a little more advanced. And we'll work our way towards some of those advanced equations. Honestly, this first category probably is still kind of the basic category, but it's important. Make sure you get the idea. We're going to use inverse operations, kind of like a good standard equation. Again, if you want, you might write something like inverse operations up here in this little corner if you're using this organization method. We're probably going to do like 2 examples for each category. I also may have like a couple pointers for each category. So if you're making space, try to plan accordingly. Okay, so first example for this category, work out nicely here. 2 cosine squared of x minus 1 equals 0. Nice little equation. In a moment, we'll talk about why this fits into this category. But for now, we're kind of hoping that you'll use some instinctive math I would hope that it's kind of instinctive here that you're going to try to isolate x. And like you've learned many times, that means you can do the inverse. You can add 1. You can do the inverse. You can divide by 2. I'm going to do those in one step. We're going to add 1. We're going to divide by 2. And now we're staring at cosine squared of x equaling a half. Again, we're trying to solve for x, so we're doing inverse operations. You always work your way from the outside to the inside. The next thing on the outside that we got to sort of hit off here is this square. So we pick that off with a square root. Good old square root of both sides. Now, when you take the square root of both sides, it's time to kind of kick into algebra mode. First off, you always get plus or minus. It's just true that when you take the square root, you now have 2 solutions that are legit. So you have plus or minus 1 over the square root of 2. You'll notice that I'm not going to my calculator or turning this into a decimal yet, but shortly we will, because now we just have one thing left to do. We have to get rid of cosine. And to get rid of cosine, as I mentioned, you've done stuff like this before. You'll do the inverse. You'll do the inverse. And now we probably go to our calculator. But as you go to your calculator, understand some stuff, mainly that you're actually finding 2 answers. So you should be doing the inverse of 1 over root 2. But you should also be doing the inverse of negative 1 over root 2. Make sure that you're comfortable with all this. I can show you up here. So I'm doing the inverse of 1 over root 2. And I'm also going to do the inverse of negative 1 over root 2. And of course, those values are x. They're also angles. Remember from that really boring lesson, anytime you have an inverse, it's always an angle. So some of these things, just to kind of be aware of what you're finding. Notice that the answer is not plus or minus 45. Okay? Rather that we're actually finding an angle that matches with that cosine statement. We could talk a little bit about the unit circle, but that angle would be over there at 135. Let's make a couple observations. Okay? It's important because when we get into some harder problems, sometimes people forget how to do the easy problems. Okay? Couple observations. First of all, think algebra. That's kind of basic. I mean, you can write that down if you want, but all that stuff we did, add 1, divide by 2, take the square root, algebra. Now, some additional things that are important. Additional things. First of all, taking the square root always gives you a plus or minus. Might be something extra that you want to add to your thinking. And then let me show you something in this example that we will also kind of add to our thinking. So we're going to keep thinking algebra. We're also going to need to have kind of a special trick in order to get ourselves to an answer here. We have cosecant of 2x minus 3 equals 0. Just by the way, it's important that you understand kind of what is in parentheses. There are no parentheses in this problem, but assumed, I always kind of hate to use that word, but understood would be that this 2x is the only thing that is with the cosecant. You say, well, what else could there be? Well, What if it was like this? Okay, well, if it was like that, it would have had to have been written that way. And that's a whole different problem, because now we're doing the cosecant of 2x minus 3. Again, it has to be understood that the way it was originally presented would only assume the parentheses are around the 2x. All right, so what that means is that we need to add 3 to the other side. Again, pretty basic algebra, but it's important that you do that first. Now, if you're a little bit sort of leery here about this cosecant, I'm with you, because it's kind of like, how am I going to do the inverse cosecant? How am I going to try to do this to both sides? Well, we're not. We're not, because we don't have an inverse cosecant button. So first, we're going to interpret this. Cosecant, we're going to interpret this as its reciprocal. Now, if I do the reciprocal of cosecant, I would get a sine function. Here's what you want to understand. If I'm going to do the reciprocal of the left side of the equation, then I have to do the reciprocal of the right side of the equation. We actually still did algebra. What was the algebra? We did the reciprocal of both sides. And when you do the reciprocal of both sides, you are within sort of the rules of algebra. You also conveniently turn this problem into a sine function, which is a heck of a lot easier to finish on your calculator. Okay, so maybe this would be a good time for me to sort of share this, again, sort of special thought here. Basically just highlighting that we're switching, I guess I said switching from, we can use the word from, but we're basically changing to a reciprocal function. But we're doing it carefully. Carefully means that you do it to both sides. All right, and I hope you understand that implied by this statement is that if you have one of the cosecants, secants, cotangents, if you have the 3 reciprocals, switch from them. If you have one of these uncommon, switch to something common. Okay, so that you can do the inverse. The inverse, sine. Sure, we can do the inverse sine. It's a button on our calculator. Now, after you do the inverse sine of a third, well, actually, you end up getting right around 19. Let's just change it to that. You get like 19.47. But after you get that 19, then you can divide by 2. All right, so we get about half of that 19 number. Again, something you can check on your calculator. Now, if we're going to round it, we get 9.74. Squeeze it down there, you get 9.74. Make sure you're good with your calculator, that you work through the inverse of a third and then divided by 2. Now, there was something about both these problems that made them basic. Okay, and that simply is that there was just one trig function. Look one more time with me, because there was a cosine. There wasn't any other trig functions on the board. There was a cosecant. There was no other functions. It always started with one function. But when we get into some of these other categories, well, we're not going to just have one function. Here, we have a repeated function. Here we have a repeated function. By the way, I would put this in the next category. What category is this? I didn't tell you yet. What do you do when you have a repeated trig function? I hope you did it a couple times on the proof party. Factor. So factoring, you're familiar with it. Factoring is always when you have a repeated trig function. I know you've heard that a couple times. That's on purpose. Here it is another time. If you want to write it down, you can. This time I'm kind of giving you the specs before we start. So again, if you have a repeated trig function, it's not really basic anymore. So we can't just do inverse operations, but we could factor. Now, you know there's different types of factoring, which we will continue to review. I hope that when you look at this equation that you kind of think more basic factoring, meaning Gcf factoring, meaning take out what's repeated. Now, when you take out a tangent, you're left with a tangent plus 1. We haven't really solved an equation like this year, but you would have solved it a couple times in Algebra 1 and Algebra 2. And just remember that the premise here is that since the equation is equal to 0, that you're able to take each of these little factors and make them equal 0. And so you might rewrite it. You might just think of it in your head. I'm going to rewrite it the first time. But each of these factors makes up like a little equation. Both of them equal to 0. Both of them able to be solved with some basic inverses. Okay. As you guys get to the point that you're obviously doing this on your own, you kind of decide how much you need to show. I do want to make sure you're aware that we're finishing the first one by just doing a nice little inverse of 0. But the other one will be doing a nice little inverse of -1. Okay. Both of these little equations we're just solving by taking the inverse of both sides. Just saying, you could find these answers using some no calculator strategies. Okay, if you're kind of feeling like some of these answers look familiar, we have found them before using triangles. Okay, if you are just curious, the triangle that would have worked for the second sort of equation would have been a triangle that had a tangent equaling -1. Interpretation, a y value and an x value of -1/1. And if you have a -1 for your y value and a 1 for your x value, then you're at -45. The reason, though, that we say -45 is because of principal values, another one of those amazing lessons from last chapter. In other words, the reason the answer is not 315 is because 315 is outside of that principal region. Relax, you can use your calculator. I'm just showing you that we have solved problems like this by thinking about simple sketches. Okay, and eventually we'll come back to that when we review for the midterm. We're only going to do one problem in that category, but I do want to highlight that any factoring problem always has to equal 0. Remember, that's like the way it works. Since the equation is equal to 0, we're able to take each factor and make it equal 0. All right, good stuff from algebra. If you're kind of feeling like this isn't too bad, good. I don't want you to think it's too bad. But the truth is, we still haven't really used any super heavy-duty math. Now we're going to get a little more heavy-duty. We're going to move into the third category, identities. Okay, using identities to be specific. This is what we've tried to train for. Okay, this is why all the blood, sweat, and tears, so that we could solve one of these equations. Now, if you were expecting some big, bad, long equation, not necessarily. The first thing I just want you to notice is that this equation has something different compared to what you've seen today. Does it just seem a little different? It says sine equals tangent. Okay, well, there's two functions up there. It's all right, but because there's two functions up there, we're going to have to use identities to try to turn it into one function. Okay, we're going to use the identities to try to end up getting, well, here it says that we've got two different functions, but we're going to try to use the identities to come up with one function. Think about it. You're not going to be able to solve this problem with a sine and a tangent. Basically, you're not going to be able to punch that into your calculator. But you're not going to need to. You're going to just turn this into one function. By the way, you're getting the subliminal messages that are sort of mixed into this lesson. So, from your training, do you feel like that there was something you would change up here? Do you feel like there's an identity that you could apply? Sine equals tangent. There really is only one thing that I would say we could change, sort of on a simple level, would be this tangent. Okay, now this is one of the things that I hope that you're feeling like that you don't need to look in your book all the time. You should be able to say that tangent is the same as sine over cosine. If you're feeling like you can say that, good. That's kind of the spot that we're trying to get you at in this chapter. By the way, I'm not trying to prove this. So since I'm not trying to prove it, I'm allowed to move things around. Yay, that's kind of what we like to do, right? We want to move cosine over to the other side. So we multiply both sides by cosine. Now be careful, if you're still working on your proof party, don't mix this kind of stuff up with that tonight. You're not able to move things side to side on the proof party. But we are trying to get down to one trig function. We're trying to get to one trig function. Pretty easy to do, right? Keep moving things side to side and get one of those functions to cancel. So we divide both sides by sine, and we get cosine equals 1. Interesting. Sort of just like that, our equation went from a sine equals tangent, two trig functions, to one trig function. And of course, everybody can do the inverse of that. Before you punch that in your calculator, or now that you did punch it in your calculator, when does the cosine equal 1? Cosine's x, right? When does x equal 1? Well, right here, x equals 1. Right here at 0 degrees. Okay, that's why you end up with 0. Let's do another one in this category. You still have some space. Secant plus tangent equals 0. Secant plus tangent equals 0. Okay, now eventually there'll be a time where you guys will get these problems all mixed up. There's a little card activity. You guys will pass some stuff around, once you've had a chance to kind of see all the possibilities. You see this problem show up on a card that comes across your desk. It's equal to 0, but don't sort of overuse that. In other words, that doesn't mean you necessarily factor. Just because it's equal to 0 doesn't mean you factor. It's got two trig functions. Okay. Well, if it's got two trig functions, We want to think identities. We want to change things. How's your training? Okay, you guys are kind of at the final phase of your training here. Something that you would change. If you change everything to sines and cosines, see what happens. Okay, you've already made a common denominator. So I have 1 over cosine plus sine over cosine. But again, kind of getting excited here because we automatically have a common denominator. Use it. Take advantage of it. Add the numerators. Now remember, everything's being done with the purpose of canceling a trig function. So nice job. Looks impressive. Look, Mom, look what I did. But the reason you're doing this is so that you can cancel a trig function. Okay, and this cosine, once it switches or multiplies over here, gone, right? It'll vanish. So you multiply both sides by cosine. But that's why that 0 is there. So we basically could watch that vanish. And again, just like that, you have one trig function. And hopefully, pretty easy one to solve. Take the inverse of -1. If you want to give your brain a little workout before you type it in your calculator, you think about the beloved, and you think about when does sine equal -1? Remember, sine is y value. When does the y value equal -1? Okay, now the reason your calculator spits out -90 is again because of principal values. Principal values meaning that's part of the domain where we have a function. Let's go to the last category. Let's see what it is. Oh, let's not go to the last category. I'm glad that I put that up there. Guess what we need to do with -90? What gave it away, right? We have to check the solution. Wait a minute. Why do we have to check the solution? Secant plus tangent equals 0. Okay, secant plus tangent equals 0. That should mean that if I plug in -90, that it'll equal 0. Right? And I hope you're kind of wondering in the back of your mind, why are we doing this all of a sudden? Now, if you do plug in -90, you get a problem. You get a problem. You get a 0 in the denominator. Okay? Because, well, each one of these has a denominator. And it turns out that when I try to do the definition of tangent, or even when I try to do the definition of secant, I'm just doing them individually so you can see that it can't be done. Okay, here's kind of the secret. Since the original equation had fractions, since the original equation had denominators, we need to be sensitive to the possibility that the solution doesn't work. You've been around math some. You know that sometimes you can do stuff, but you end up with a solution that actually does not work. You end up with a value that doesn't check in the original problem. Now, let me say it again. The reason we have to check the solutions is because the original equation had denominators. Okay? Technically, we should have checked this one because this had a denominator. It works though. Okay, if you don't trust me, you can check it. Okay, same thing over here. tangent has a denominator. Although these do work, there were no denominators over here. Okay, so if you have a denominator, you have to check the solution. It is something that we'll have to remind each other of. It doesn't happen a lot, but it does happen sometimes. All right, now we have that thought, but what I want to do is go to this last category.
What do you mean by denominator?
Well, like tangent, that's a good question. Tangent kind of in its essence is sine over cosine. So what I really mean is that it's sine over cosine. Yeah. All right, so last category. Last category is kind of the special one. You can call it whatever you want. Basically, it's kind of like sometimes we have to be a little more magical. Sometimes we have to basically know that there's some more creativity, some more math that we can use. Again, you can call the category whatever you want. What I'm really trying to say is that sometimes there's a little bit more required. There's nothing about this equation that appears that complicated. It just says cosine equals 1 plus sine. Cosine equals 1 plus sine. But when we try to do kind of what we've done already, we sort of get stuck. You know, what identity am I going to use here? Am I going to just be able to change cosine? Okay. There is no like just cosine identity. We don't want to start flipping things and getting reciprocals. That's just going to make it worse. What about something like this? What about like dividing everything? Now, I'm going to warn you that this is not going to work, but sometimes we need to learn by seeing things that you can't do, but maybe it'll work next time. But just saying, sometimes a student will suggest that maybe I could divide. I mean, we actually did this back on day 1. Here you get the number 1. That's nice. Here you get tangent. But here, I really just get a different version of cosine. I get secant. And so, again, this is wrong because when all the dust settles, I'm still staring at 2 trig functions. Okay? There are some problems, though, that if you just divide them, good things will happen. Not this one. So we need to be a little more magical. It turns out that correctly getting squares involved allow us to kind of delve into another group of identities. So this is correct. And by the way, it's also correct algebra, square both sides. But the reason we're squaring both sides is because it opens up that other category of identities called the Pythagorean identities. Okay, so we're squaring both sides. Now, please do the FOIL method correctly with 1 plus sine. That's going to give you 1 plus 2 sine plus sine squared. Again, we're being careful to do the algebra correctly. Now, here's where your training should be sort of kicking in, because maybe you're just waiting kind of for me to tell you, but I want you to realize that every problem we've done has had the goal of having 1 trig function. Right now I have 2 trig functions. I have a cosine and then I have sines. I'm counting it as 2 because this is one type, sine is another type. We want everything to turn into the same type. Any ideas on what we could change and how we could change it? How we could change cosine squared? 1 minus sine squared. Now, notice, everything is sines. Okay, good. That means we're on our way. You can't solve a problem with 2 different trig functions. Okay, but you can solve a problem with the same trig function. You know, so now what? Well, gather things up. Gather up your belongings. Move every sign together. Okay, so things like this should be kind of common, like adding sine squared and gathering that up. How about this 1 right here? I could subtract it from both sides. I could cancel it because that's what happens. Now, you'll see that I'm also sort of conveniently making my equation equal 0. Yes, indeed, we're making the equation equal 0. Because look what we have. We have repeaters. Oh, I erased it, but we have repeated trig functions. Okay, now the problem is kind of opening up that factoring category. Now, listen, those 2's, they're just kind of like extra weight there. You could factor out a 2. You could factor out a 2 sine. You also could just get rid of those 2's. You could basically divide them away. So if the 2's kind of bugging you a little bit, it's kind of bugging me. And again, I want to show you that there's no reason I can't divide out that 2 and just make it dissolve with the 0. And you can kind of do that whenever you want. I'm going to do that right now by just erasing it. Make sure you're comfortable with where the 2 went. Okay, but we factor it. It's sine times 1 plus sine. And yeah, you know, just like any factoring problem, that means that sine equals 0. That means that 1 plus sine equals 0. You don't need to show this if you don't want to. What I'm saying is you could go to your calculator and finalize each of these x values. Make sure you take the inverse. Take the inverse. You could also think about the unit circle if you want to give your brain a little workout. And maybe you're not surprised to get 0 and negative 90. You don't need to check those answers technically because the original problem had cosines and sines. And again, as I tried to clarify with you, those do not represent fractions. Listen, we squared both sides. It's kind of the little magic, okay? But here's what I don't want you to do. Sometimes students will start to square both sides for every problem. You know, like if we do go back to this original sine equals tangent, you know, it didn't require us to somehow square both sides because we could just accomplish it with basic identities. I guess what I'm saying is think basic before you get into something magical. All right, but squaring both sides sometimes is kind of that is needed because nothing else will work. We have some other equations to talk about, but this is kind of like a day 1. Okay, and then there's some homework. Back to the book again. Now that's kind of like a nightly homework, and it'll provide another opportunity to put some problems on the board. We're sort of getting close to running out of those opportunities, so think about that for tomorrow. I could check the homework. You also have a proof party. I know you have a couple things going on. Oh. I guess I could put that up there, but I'm just trying to basically say, think about how you can use some legal algebra. All right, and again, sometimes you have to think a little bit outside the regular box.